Hi guys, welcome to today's show. So far we've been looking at financial maths, specifically growth and decay. And then we've been looking at various concepts under that. And all these concepts are just a build-up of what it means maybe to save money or to invest money, or what it means to also even consider when we talk about interest and loans and all of those things. But now today we're actually going to look at compound decay and timelines. Compound decay will then be the opposite of compound interest. It's just the same thing but with now a minus sign. But let's just quickly do a recap of everything that we've kind of looked at so far and then get into today's lesson. Now, firstly, remember our big idea has been finance, and under finance we've looked at growth, which was simple interest and compound interest. And then we've looked at simple interest and what it is all about, which is an interest that is constant in your investment. And we've looked at straight line depreciation or decay, where the goods and services that you actually might be having at that time, they going down at the very same rate. And then we've also looked at compound interest, but which is an exponential growth. And this means that each and every month you are not getting the same amount of money in terms of interest. You're getting interest on interest. You'll hear that when people are talking about compound interest, they normally use terms interest on interest. That's why compound interest is actually the way to go. Now, the very first question I want you to think about, which we've been looking at this question, is how exactly do people save or grow their money? And then also to you now, what has been your best choice of saving your money? Let's say you're trying to get those shoes that you know for a fact that at home they're not gonna get you or anything of that sort. And then they say, no, we can give you an extra money just to see whether you can save. What did you do to try and save up for that particular thing that you want? Now, for compound growth, remember that our keywords had to do with term and length of time, and we said we deliberately used term and length instead of number of years, because in compound growth, you don't always get interest on a yearly basis. You can even get it on a monthly basis. We also looked at our principal amount, which was the initial investment amount that you start with. We also looked at the accumulated amount, which is actually the amount that you get after a certain period of time. Also, remember at one lesson we looked at inflation. Inflation had to do with the rate at which goods and services grow at, right? So they increase by. You remember that I think a few years ago bread cost this much, now bread costs a lot of money, and then later on as well bread will be costing more. It is all because of inflation. We also looked at the concept of interest rate. Interest rate was when we're talking about nominal and effective interest rate. Then lastly, we looked at also the compounding period, which means how often do you get your interest. Remember, just a quick reminder of our formula for compound growth was A is equals to P open bracket 1 plus I to the exponent of n. Where the labels are, my A is the accumulated, P would then be the principal amount, and then I would be the interest, N would be the number of times interest is earned. Remember that I said we can always look at A as also what we call future value, and we can look at the principal amount as the present value as well. So just remember that, because at a later stage, that's what we're going to be using as the financial mathematics terms. Also, there was a conversion between nominal and effective interest rate. So the formula to do that was 1 plus I effective, is equals to 1 plus I nominal divided by m to the exponent of m. Where the labels are, you know that I effective The effective already tells you that that's effective annual rate, and then the norm means nominal annual rate, and then my M will then be the number of compounding periods per year. Now, compounding periods per year, I said at the end it says per year. What this specifically means is we don't look at nominal and effective interest rate over a longer period of time. No, we only look at it on a yearly basis to say, what did they promise you for the whole year? That's the nominal interest rate. But what did you actually get because of the compounding? That's the effective interest rate. I will repeat that again. What did they promise you for the whole year as the interest? And what did you actually get because of the compounding period? What they promised you is the nominal, and what you actually get will then be the effective because of the compounding period. So please remember those two. This formula, you will need to memorize it and know how to use it, because it's not going to be part of your information sheet. They normally do not include it there. So you need to really know this formula, because there will be questions where you need to convert between the two. Also, you need to remember that certain assets normally actually lose value over time. A car that I bought at 20,000 today, tomorrow definitely it will not be worth 20,000. It will be worth way less than that. Also, these assets are normally like vehicles and equipment. So your cars, your buses, your taxis, your tractors, those are all the vehicles that we are talking about here. And then the equipment can be a TV, it can be a computer, or a playing console for that matter. The loss of value is normally called the depreciation or decay, which means one and the same thing. And then depreciation is always something that occurs yearly. Now, guys, just on a general basis, remember that when we look at cars, we normally look at the year model. The year model normally does what? It influences the price. So now if I look at a car maybe from 2001 and I want to buy it at this present moment, definitely it will not be the same as it was when it was in 2001 when I was buying the car. It will be way less than that. Why? Because it is a very long period after that. So that's why you need to look at this. But if I look at something that I bought 2 months ago, it might still be closer to the very same value that I bought it for when I sell it 2 months later. So you need to look at all of those things. That's why depreciation happens on an annual basis and not necessarily on a monthly basis, because after 1 month you haven't really used that thing that much, so you can always negotiate your way around it, though you know that it will still be at a percentage that is less than whatever that you bought it for. Now, our main concept now is decay, right? So we've looked at the straight line decay. Now we're moving on to the reducing balance one. And the keywords has always been scrap value or book value, which means one and the same thing, but at times they normally use in the value trade in value. So at times they also call this the trade in value. The formula that we normally use to calculate depreciation on a reducing balance method is the same as the formula for compound growth, but with a minus now. So this here is actually supposed to be I in a small letter, although it's a capital letter there. So that's actually supposed to be a small letter. And then our A is the scrap value or the book value, or what it is worth after a certain period of time. And then the principal amount will then be the rate of depreciation, which is our I. And then lastly, it will be the number of periods. So how long has this particular asset been with you that you are trying to sell? But let's try and put all of this into perspective with a question. Now, you buy a new console, right? Let's say a PlayStation 5 or an Xbox Series for 12,500. What will this console be worth in 3 years' time if its value decreases at a rate of 15% per annum according to the reducing balance. Now, if you look at this, there is nowhere where I'm going to be saying to you per annum compounded. Per annum compounded. I will never say that. Why? Because depreciation is a yearly thing. It has nothing to do with months or anything like that. It normally is calculated on a yearly basis. So you see compounded something on depreciation, there's something wrong there. Now, on a reducing balance method, remember that we are looking at compound growth, but with a minus. Now, we just need to write down all the values that we know. We know that the principal amount is actually 12,500. Our interest, let me just go back, it's 15%. So this is 15% per annum. And then our N, is actually 3 years, right? So this is 3 years. And we are looking for the A value. Now, to calculate this, I will first start with the formula, 1 minus I to the exponent of n. And then I'm looking for A. I know what my P is. That's 2,5, which is the same as like 2.5, into 1 minus, not plus. See, one of the common mistakes that we normally make is as soon as you see compound something, you already think compound interest. And this is going to be 0,15 to the exponent of 3. Then, guys, you really do not need to try and crack your brain here. You have a calculator for a reason. So you just go to your calculator, substitute everything as is, 1 minus 0.15 to the exponent of the 3. And you find what the answer is. Now you can see, if I was to find a value that is greater than the 2,500, then I would really have a heart attack, because there is no way that I'm using depreciation and I must get a value greater than 2.5. So that's one of the ways you need to look at when you're trying to do your maths, so that you know whether you are on the right track or not. So this is 1535. 1535. So that's what it will be worth after 3 years of having this console. So you can see that although we love these gadgets of ours, depending on the rate of depreciation, if I buy it today, definitely tomorrow when I sell it, it will be way less than that. But then it is all in the fun of using it when you are just getting it at that time. Guys, that's all from me for now. Let's take a quick ad break and I'll be back with some more. Stay tuned. Hi guys, welcome back. So we are still busy with some finance, which is growth and decay. The first segment, we've actually looked at what it means to have compound decay. Now we're going to look at timelines. Timelines are a tool that actually assists us to see when somebody is making maybe multiple deposits into their account, or they making multiple withdrawals, or they then having a change in interest. Because you know that at times when it comes to our country, there will be at times where interest is changed because of the economy at the time. So when that happens on your investment, we normally use a timeline just to try and see what exactly is it that you will have and project something that will happen maybe after 5 years of your investment or after 10 years of investment. It might not be accurate all the time, but remember, if you do your research right, then definitely it might work for you. So let's look at what timelines are all about. Now with timelines, it talks about the time value of money. Time value of money is all about how do you get your interest? How often do you get your interest? What does your interest change to? how much are you adding after a certain duration of time? How much are you taking out of that particular account? So that's what the time value of money is all about. Now, we normally use the symbols T0, T1, T2, etc. like that to represent the point at which we are on the timeline. So T0 will be when the investment is starting. T1 will be after a year the investment has been there. T3 will then be after 3 years. T4, T10, like that. So those will then be our terms that we normally use or symbols that we use. Now, when compound interest is used, the money, it can always be moved forward and backwards on a timeline depending on what the interest is all about, and also depending on whether you are actually now taking out money or putting in money. But what this means specifically is that when you're moving forward, you n times, you multiply by 1 plus I to the exponent of n, and the n must now be a positive, right? Because remember we said you times by the power of that. But if you're moving backwards, it will then be a minus. Sorry. So remember that on a number line, guys, going to the left, it's always a minus. Going to the right, it's a plus. So it means when I'm moving forward, I'm adding. And I'm moving backward, I'm subtracting. Hence the plus and the minus. Now, let's just try and consider a comparison between 1,000 rand and 1,200 rands in 2 years' time at 10% interest rate that is effective. Now, if we're to use a number line for this, at T0, you can see that the amount is actually 1,000 that the person is putting in. At T1, there is nothing that is happening. They're still gaining interest. And then at T2, the amount now became 1,200. So we need to look at what exactly does this mean. Now let's just look at this. At T2, you can see that if I wanted to calculate what happens to my 1,000 rand for 2 years, I would then use the compound interest formula, right? So which is P into 1 plus I to the exponent of n. Remember, this is about growth, right? And not decay. So my P there will be 1,000 rand into 1 plus, then my interest, they said, is 10%. So that's actually going to be 0.1, and this will be to the exponent of 2 years. Then we want to see what will happen at that point. So remember, what did we say? If you're moving forward, you multiply by 1 plus I to the exponent of a positive n. Now, if you go back to the calculator now, this will be 1,000 into 1 plus 0.1, and this will be to the exponent of 2. And then this, you can see that it's 1,210 rands, right? So it's not necessarily that it's going to be just strictly 1,200. So that's the amount that you actually going to have. So you can see it's slightly still closer to that, and that is what is happening at that point. So the goal here is to move forward. But now at T0, it means we are now moving backward, right? And if we are moving backward, we then need to actually use the very same formula that we have, 1 plus I to the exponent of now negative n instead of a positive n. And then from there, you can then substitute what you have. So let's just see what will happen on the calculator if I do that. So that will be a negative there. And then you can see that it was actually worth 826 rands, right? So if I wanted to move backwards in terms of me having the 1,000 rand, 2 years back, the 1,000 rand was actually worth 826 rands and 45 cents. So That's what we are talking about when we are talking about moving backwards and moving forward on a timeline. Now, we have what we call a change in interest rate as well. An interest rate, when it changes on a number line, we normally show that using something like a wobble and writing what the interest rate is there. That whole point is to show you what the interest was and what did it change to and what did it become continuously so. So that's the big idea here, to look at how did our interest change as you were moving forward or as you were moving backward with your investment. Now, with this question, we have a guy, Sibusiso, right? Sibusiso then deposits 15,000 into his bank account and leaves it in the account for 5 years, right? So Sibusiso deposits that and leaves it for 5 years. But for the first 3 years, the interest is actually given to him as 8% per annum, compounded monthly, right? That's for the first 3 years. So from T0 to T3, that's what Sibusiso is getting. But thereafter, meaning for the remainder of the investment, now Sibusiso will then get 9% per annum compounded quarterly, so 1% more, but at a different compounding period. How much money will then Sibusiso have in his account at the end of 5 years? So let's look at a number line for this. So you can see, guys, remember that we said N will be the number of times the person is getting interest. So between T0 and T3, Sibusiso is getting interest 36 times. So it's for 36 months. And the interest that he is getting is 0.08 over 12. And then for the remainder of the investment, he's actually getting the interest for 8 quarters. Because remember, in 2 years, I have 8 quarters. And the interest he's getting is 0.09 over 4. And therefore, if we wanted to calculate for this, right, I will say this is A is equals to, firstly, I will want to find how much interest did Sibusiso get for the first 3 years, right? So that is 1 plus I to the exponent of N. And therefore, this will then give me, remember that the amount that Sibusiso invested was 15,000. 1 plus the I is actually 8%. So the I is 8%, which is 0.08. And this was for on a monthly basis. And this was to the exponent of 36. And then you find what that amount is. That's the first calculation, right? So let's just perform that calculation quickly. So Sibusiso invested 15,000 and he was gaining an interest of 8%, 0.8 over for 12 months in every year. And this was to the exponent of 36. So you can see that now his investment is now worth 19,053 rands and 56 cents, right? So this will be 19,053 rands and 56 cents, right? Although I'm rounding off here, that's not what you're supposed to do. Remember that. You need to leave it as is. But remember, I have it on the calculator, so I'm going to still use it from a calculator point of view. So for the whole now duration, which is for the last 2 years, and for the last 2 years, that's how much Sibusiso will have at the end of the 5 years. It will be the principal amount, which will now be the A3. So that's what he got for the 3 years, into 1 plus at the changed interest, which is 0.09 over 4. Why? Because this is now compounded quarterly, right? And this is to the exponent of, remember, it was for 2 years, so that means it's 8. So that's what we will have there. And then if I go back to my calculator, remember that's still my answer. So I'm just going to say answer, open bracket, 1 plus 0.09 over the 4, and this will be raised to an exponent of 8. And then, you see, so at the end of the duration, Sibusiso will have that amount. But now let me show you something that's interesting that you can do here. Instead of doing it in bits and pieces like this, you can just straight up go to and say 15,000, and then for the first 3 years, we know that the interest was 8% compounded monthly, and this was for the first 3 years, right? But this whole amount was reinvested because he left it in the bank, and this was reinvested at an interest of 9% over 4 because it was compounded quarterly, and this was for the last 2 years, right? Voila, it gives us the very same answer. You can see, easy peasy, lemon squeeze. So you can just do one long calculation. Why? Because you're moving forward, or you can do it in bits and pieces, depending on your comfortability there. Now we have what we also call multiple payments and withdrawals. So here we have Cheryl, who has a bank that offers her 3% per annum compounded monthly, right? So she's getting 3% per annum compounded monthly on her savings account. She opens the account with a deposit of 12,000, and then a year later she decides, no, now I have an extra amount in my purse. Let me just go and deposit an extra 5,000. Another 2 years later, she decides to also do what? To withdraw now 8,000 because maybe there is now an emergency that came up, so she just needs to take out that amount. So you can see that for the first investment that she made, she deposited 12,000, and then a year later, she decided to say, I'm going to deposit 5,000, right? And then 2 years later, she decides again to do what? To say, no, let me now withdraw this. It might be an emergency that came up, or maybe she saw something that she would like to get, or she has to maybe put up a deposit for something that she's trying to buy. Now, we want to know how much money she will actually have in her account after 5 years, right? So if we look at this from a number line perspective, you see what is happening here. So for the first year, the amount was there, which was 12,000. And then at the end of the first year, she decided to deposit the 5,000. And then for the 2 years now of leaving all the money that she deposited, which was gaining the interest that has changed now to the other interest rate that she actually got, but at the very same rate, which is the 3%, right, compounded a month. So in this instance, it means that the interest did not really change, but what changed is the withdrawal now. She decides to withdraw. The reason for the minus there is to show that she actually withdrew from her account, and then she leaves the balance. So for this duration, the interest was being earned, and then here she took out money, and then the balance that was there was left for the remainder of the investment for it to gain some interest there. So if we do a calculation for this, we will then say that this is actually going to be the 12,000, right? The 12,000 gained interest for the whole duration of the investment until T3, before she actually withdraws this much, right? So I will then calculate this for the 3 years at a rate of 3%. 0.3 over 12. So this is for the first 3 years, it was that, right? And then I will add how much? The 5,000, which actually gained interest for 2 years before she withdrew. So that will be for the 5,000 into 1 plus, the interest is still 0.03 over 12, but now this is for 2 years, meaning it's going to be 24, right? And then from whatever we get there, we're going to subtract the 8,000. So let's quickly do the calculation. This will be 12,000 into 1 plus, the interest there is 0.03 over 12 to the exponent of 36, right? And then we add the other amount that gained interest for 2 years now. This gained interest for 2 years, 1 plus, same, 0.03 divided by 12, and it was to the exponent of 24 because it's for 2 years. And that's how much she then had after 3 years. She then decided to do what? To withdraw the 8,000. And that's what she was left with. What happened to this? This gained interest for the last 2 years, and the interest was still the same. So I'm just going to say answer, open the bracket, 1 plus the fraction 0.03 divided by the 12, because it's still compounded monthly, and this is raised to the exponent of 24 months because it's for the remainder. And then that's what the total investment account amount was at the end of the duration. So guys, this is the big idea here. The big idea is to look at what is happening. Are you withdrawing? Are you depositing? Or are you changing interest? Maybe after a certain number of years with your investment, you go back to your bank and say, guys, I've been a very loyal customer. Can we now negotiate what is happening here? Or maybe another financial year that takes place. You know that banks normally review their financial status, and then they say, okay, now we increasing the interest, or we decreasing the interest. So that's what we're looking at. And when you have that, you really need to be able to then solve that using what we call a timeline. And the timeline is really, really powerful, especially if there is multiple deposits, change in interest, or multiple withdrawals that the person is making. Remember that we use T0, T1, T2, T3, T20 to represent the time in terms of where we are at that point. So the number T0 will always mean the start of the investment. And then you saw that at times we use a plus and a minus when we show the amount that we have. So at times when it's a minus, it means it's going out. When it's a plus, it's going in. Or it can be an arrow going in or an arrow going out. They both mean one and the same thing. So that's all you need to look at. Guys, we're going to go to a quick ad break, and I'll be back with some more. Stay tuned. Hi guys, welcome back to the last segment of the show. So we're just going to do a quick recap and then answer a few questions, just so that we tie up everything that we've kind of looked at with the previous lessons as well. So that's all that we're going to do now, and then wrap up this concept and see exactly what is financial mathematics, especially growth and decay. So let's just look at it. So far, remember that our big idea has been finance, and then so far we've looked at simple interest, we've looked at straight line depreciation, we've looked at compound interest, and we've also looked at the reducing balance. You just need to remember that the equation for compound growth is given by that, and our definitions of all the letters will be: A is an accumulated, P is the principal, I will be the interest, and then N will be number of times interest is earned. Please remember, not necessarily the number of years, because we're dealing with compound growth. It's the number of times you are getting the interest in the duration of your investment. Now, the formula to convert between the nominal and the effective interest rate, just a quick recap. Remember, it is given by that. And then our definition is I effective is the effective annual, and then I norm is the nominal, and then M is the compounding period. Now, let's just look at a few questions and see exactly what all of this ties up to. Now, the value of a vehicle worth 200,000 depreciates at the interest that is 12% per annum, and the principal amount or the present value when you bought that the vehicle was 200,000. After 5 years, you need to calculate what the value of the vehicle is going to be if the depreciation is according to the reducing balance method. Remember, guys, you will be told what method we are dealing with if it's a depreciation. Even if it's a just simple interest or compound interest, you will be told what we are dealing with so that you know what is it that you need to do. Now, these are all the things that I have. Let me just change my pen. The principal amount is 200,000. My interest is 12% on a reducing balance. We specify which method are we using, and then this was for 5 years. So to calculate this, remember you start with the formula y1 minus I to the exponent of n, and then my p-value is the 200,000 into 1 minus my I is 12%, so that's 0.12, and then this is to the exponent of 5. Please remember that there is no compounding period when we talk about depreciation. Now, if you go back, okay, I hate this. Now it was the calculator. Please just count me down. Yeah. Right, so if you go to our calculator here, you can then see that we're going to have the 200,000, which is what we are dealing with, and that's the value of the vehicle. 1 minus, the interest is at 12% to the exponent of 5. And then the value after 5 years is going to be 105,546. Right, so this is going to be 105,000. Let's just verify the values. 546. 546 rands. And a couple of cents there. So you will then conclude. Therefore, the value of the vehicle will then be. But remember, they just said calculate. At times, you conclude when they ask you, what will this be? How much will it be? But if I just say calculate, remember, you just need to calculate and give me my answer. Another question. So Ziad buys equipment worth 80,000 for his business, right? So he's starting a business, and then he goes to the shop and they say to him, no, you would need to spend 80,000 for all the equipment that you need. It might be a logistic company, so it might be computers or anything of that sort. But now he plans to sell the equipment at a depreciated value after using it for 42 months. So remember, we said depreciation is on a yearly basis, but here they're giving it to us on a monthly basis. So you will need to first convert how many years are in 42 months. All right, so depreciation is calculated at 20% per annum on the reducing balance. Now what we want to know is what can he sell the equipment for? Because after all, remember, to sell the equipment, it does not necessarily mean that he's just selling it because the business is not there anymore. But it might be to want to renovate, and then now I have more clients, so I need maybe a faster equipment or a better equipment. So what we then know here is P is the 80,000, I is the 20% reducing balance, and then N is the 42 months. So 42 months is the same as 3 years, which will then be the 36 months, and then I'm going to be left with 6 months, which is actually going to be 0.5. So it's going to be 3.5. Now remember that 3.5 in financial maths is there. Now, one thing, guys, that I always see people doing is I say, how many times will you multiply this by, or how many people are there? And then somebody will write the answer as 2.5. Now, I never understand that. If you say 2.5, do you mean there is 2 people and then the other person is half? Because then that's what it will mean. But with this, because we're talking about numbers, if I say 2.5, 3.5, I'm saying it's 3.5. Right? So if it's 3 years and a half, so it means it's 3 years and 6 months. So it does make sense here to actually have comma something. But if I say how many are these, then you know you will need to make sure that you understand the context of the numbers that you're writing. I just thought that's one of the things that is interesting we normally hear people say. Now, what we're trying to do is to find A as well, and this will be equals to the 80,000 into 1 minus, my interest is 0.2, and this is to the exponent of 3.5. Remember, please, you do not use the months here, you use the 0.5. So this is going to be 80,000, yes, this is 800 actually, so 80,000 into 1 minus 0.2 to the exponent of 3.5, and this will give me 36,635, right? So this will be 36,635, and how many cents will this be? And 74 cents. And 74 cents. So this is how much then the person will sell their equipment for. So it might be that this is not really enough, but that will be the money they will get, and then maybe they will need to top it up to get a better equipment at a later stage. Now, Thomas actually bought a printer for 4,500 and sold it 3 years later for an amount of 1,200. What was the annual rate of depreciation if the reducing balance method was used? So here, what we're going to look at is we want the value of I. So this is A is equals to P into 1 minus I to the exponent of N, right? So this is 1,200. Remember that A is always less than P when we talk about depreciation. And this will be 4,500 into 1 minus, not plus. So this will be 1 minus I, which I do not know, and this is to the exponent of 3. So on a calculator, quickly, if I substitute this, I will divide both sides by the 4,500. So divide by 4,500, I get that. And then I will need to say 1 minus the answer. I get that. Oh, before we get to the 1 minus the answer, so I will say plus 1. What's happening here? So let's just do that quickly again. 1,200 divided by 4,500 is equals to that. I will need to take the 6th root of this, so I had made that mistake there. Please pay attention to those things. And then I would need to say 1 minus my answer, and that will give me that. You multiply this by 100, it means that's 19.77%. So I will be 19.77%. Now, these other questions, I would really like you guys to look at them and then try them at home. So Thabo sells his business for that amount when he is 32 years old. Now the goal here is to know how old will he be when he decides to do certain things. He decides to save the money for his retirement, right? then he deposits the money into a pension fund where the interest that is earned is 14% compounded annually. Calculate how much he's going to have when he is 65. So automatically you know that it's when after 33 years. So you will need to do that. And also, one last question that you will need to also please look at is, if they say a car rental company buys a fleet of cars at a cost of 3.2 million, you need to calculate the book value. Remember, book value will be the depreciated value. If the interest is 16% per annum on a reducing balance, you will always be told. I will keep on emphasizing. Then lastly, calculate the cost of replacing the cars at the end of 5 years. So guys, so far, what we've actually looked at, you need to know that with compound decay, it's always on an annual basis. It has nothing to do with a monthly basis or anything like that. But our main big idea has been finance. We've looked at simple interest, straight line depreciation, compound depreciation, and now we've just looked at our reducing balance. So guys, in everything that you do, you need to understand what method are you using. Is it simple interest or compound interest? They specifically tell you. Is it decay? If it's decay, is it straight line or reducing balance? And then you also need to look at how to convert between a nominal and an effective interest rate. Guys, that's all from me. Until we meet again.